everyone. Good to see such a good turnout, and I think we should say a special thanks to Steve, actually, for organising all this. He said it was all his own work, so thank you, Steve. So the earlier panel session, obviously, was focusing around testing and specification. This sort of builds on that to talk about how we go about sourcing that steel using tools and specification. Questions available via Slido, as they were before, and we'll probably pick a couple of points during the discussion to take those questions. Just to briefly introduce myself and the panel. So I'll let them give a bit more detail about themselves, but got Roy from Cleveland, got Andrea from, I should know this, I've not met before, from Useful Projects. Sorry, Andrea. Christian and Diego and Tom. Tom's got two hats on, but he can talk about that when you introduce him. So, introduce myself. I work for Great Portland Estates, or GPE. I'm not an engineer, so please, no difficult questions. Penny was far more qualified to do this than I am. But where my link is here, we started talking to Elliot Woods probably about 2 years ago we've been talking about circular economy for a good few years now, but we started talking about how we could potentially reuse steel between two of our projects. I must admit, when we were talking about this 2 years ago, I was like, this is years away. This isn't going to happen for 5 years or so. But here we are, 2 years later. We've taken the steel out of one of our projects, and we're putting into another project using 90% of the steel from one building, rebuilding it using 80% reused steel, and putting the rest of it back into the market. So a great story in its early stages. Lots of lessons to be learned, I'm sure. A lot of lessons we have learned, and there'll be a lot more lessons to come, and we'll come on this list later. I think it's very important we share those lessons. So I think the next challenge will be how we go about move on from using it between two buildings to try and finding this still elsewhere for new projects. And hopefully I'm going to learn a lot today from this discussion about how we go about doing that. So to pass over to these guys, Roy. Do you want to give a quick intro? You've got 1 minute, apparently, from Penny. So
Okay. Roy Fishwick, Cleveland Steel and Tubes. So we've been repurposing, reusing pipe for 50 years this year, actually. I've been at it for 30-odd. Reused sections. We actually used to do them back in 2000. When CE marking came in, we stopped because the market wouldn't entertain it anymore. And now we're having to try and get back to where we were, establishing inventory and the understanding in the marketplace. And there's a lot of this circular economy stuff's exactly that. We're all trying to do things that people before us used to do without batting an eye. That's the process we have to go through.
Hi everyone, I'm Andrea Charlson from Useful Projects. I'm a recovering engineer, environmentalist, sustainability consultant and researcher. And I've been focusing on circularity in the built environment for over 10 years. And most recently kind of looking at these more systematic barriers and enablers.
My name is Christian van Maaren. I'm one of the founders of the Excess Materials Exchange. We describe ourselves as a dating site for secondary materials and waste. Been around for 7 years now. And basically what we do is that we record data on passports, which I think is now becoming a household name, in especially the built environment. We enable the tracking and tracing of those materials using QR codes, barcodes, RFID tags, or whatever you can track these materials with. The passports themselves provide information to also do impact assessments, so you can make better data-driven decisions on what to do with these materials. And then we have, sorry for all these buzzwords, but we have an AI and machine learning matchmaking, a number of matchmaking tools that then help us find high-value next uses for the materials on our platform.
Hi, I'm Diego Padilla-Philipps. I am a structural engineer, and I work for a company called WSP. We are one of the largest engineering firms in the world, and I lead the net zero and decarbonization strategy for building structures. 3 years ago, we made a commitment to halve the emissions from all of our designs and advice, and I am responsible for delivering on that.
I'm Tom Howarth. I've got a structural engineering background. I've been working on the steel reclamation project on the actual deconstruction site. So I was there with a pen and tape measure, watching all these steels come out. And then I followed the steel over to the stockholder side with EMR, and I'm working, developing the tools and systems that we've got going on there.
Okay, thanks all. So I think the first question, probably into two parts really. First question might be, first part of it might be quite easy. Second part, maybe not. How much reused steel is available, and how do we go about making it more available? You can ask Roy first.
My candid answer at the moment would be nothing like enough is currently available. There are inventory out there. There's obviously a huge building stock with this stuff sat in there. What I think is happening at the moment particularly is that the demolition contracts that are in place are older contracts than before this argument had advanced. There's a lot of question marks over how you get material out of the building now based on a contract that might have been agreed 18 months ago because somebody's got to stand that cost and they're not mad keen. The demolition industry and the scrap industry particularly are incredibly efficient at getting things down in bits. So they're not at the ground level, and I've seen this on sites a few times where I've been to look at the site and you straight away get the impression the man physically doing it isn't going to be very helpful when it comes to recovering this stuff for you. So it doesn't matter how it's come down through the system. So there's a lot of material out there to have. We don't know how much. I don't think anybody truly has a handle on it, but there's a hell of a lot more than is currently getting into the system. But there's not a big inventory sitting right now. Personal thing on this as well. One of the issues that we're having is that I'm trying to hold inventory for people who tell me they have live jobs. So I've only got about half my inventory currently available to people because the other half is supposedly going to somebody else to do something else with. And it doesn't. So it sits there reserved, unavailable for 6 months, and then eventually I get to find out that somebody decided to make a bloody great hole in the 5th floor and that steelwork doesn't work anymore. So there's those sorts of things as well. But I'm confident. We used to do this. I'm confident ultimately. And the other thing, sorry, just to say very quickly, is this steel that people don't recognise a need for doesn't have to be used by those people. You pay the same for a piece of steel for a gate post as you do to put in top of your London buildings. So it's about rescuing it and recovering the carbon. It's not about rescuing what you know you can do something with. Let Bill's here as well. Let the likes of us decide what can happen to it. We'll tell you soon enough if we don't want it. But these decisions are getting made too early in the process.
Why do you think that is? No, why do you think that is? Why do you think it is?
Most of the people that are involved in the process early aren't commercial. No, I was less polite than that when we spoke earlier. So the decisions have been made in engineering terms, but actually what you're talking about is a business model. It's commercial. It impacts all the businesses commercially. And that's the bit that isn't really being allowed to express itself at the moment. There's loads of engineering aspects, loads of technical questions and queries. But the commercial thing, I think everybody in this room will have a job that they know damn well isn't going to work for carbon if it doesn't work for cash. So we've got to keep both of those things in focus.
Christian, do you want to?
Yeah, and I mean, I would say, just adding to what Roy is saying, there's an awful lot of material out there that is not being used optimally, that we don't have access to as for a new design or a new building or whatnot. But I would also like to add to that, there's a lot of materials in other sort of sectors that can also be made available. Like, we're based in the Netherlands, and there's an interesting building now being built close to a train station, which is a bicycle storage facility, which in the Netherlands are quite huge. Although I've been in London now a couple of months, and there's a lot of cycling happening here as well, but maybe not as much as in the Netherlands. And they've designed that building using materials coming from the rail infra operations. So these are rail tracks, these are elements coming from decommissioned trains using as a facade. I would say, there is a lot available, and it's also quite interesting to look at other sources of these materials, for example, in infrastructure. Because in the end, I am by background an aerospace engineer, but I'm an awful, maybe same as sort of a recovering engineer in that sense. Steel is steel, and I think you can repurpose it for new purpose and give it a new life. Maybe it has the hidden ambition to be something else. So I think the challenge really is, and that's why we're all here together, that we can unlock that and make these materials available to giving it sort of like a new lease on life, as they would say.
Okay, anybody else? Any thoughts? Tom?
I think there's definitely a role of understanding that we know there's a lot still available, but there's a big role in terms of understanding, is it actually suitable for reuse, and what are the challenges in actually getting that? So there's definitely a role there for kind of looking at, even before the decision has been to deconstruct, in terms of actually having some kind of surveys or assessments of quantity of steels in the market, the potential for reuse, and then also what is the kind of challenges to get it out. And if we can start when we do have case studies that are developed that kind of tell us how to overcome these challenges, sharing those lessons, and then we can start kind of pushing the methodologies.
Yeah, we're leaking away so many materials because everything that's not being reused, I found, at least in the Netherlands, and I think it's the same here, that between 70 to 80% of all the steel that's being sold as scrap is basically being sent to Turkey and China, which is like, for a lot of reasons, maybe undesirable. And also, just to add, I came across another example where things like temporary works, which are often also steel structures, some of these designs are like 2,000 tons, are only used once. So they're very heavy, expensive, single-use coffee cups, basically, which I think, there's so much untapped potential there that we'd love to, make use of, together with you guys, of course.
I think one of the other changes that's needed, it's kind of touching on Roy's point, is that the decisions are made very early on, and they are made about whether there's reuse potential kind of on the building or for the site, because it requires a different process to a normal process. The normal process assumes a certain demolition program and usually not very enough time. And if you're going to dismantle anything for reuse in your own building, in another industry, you have to do a different process, and that has to be built in from the very start of your project programming process. If you are like the developer or the project manager, those are very early viability decisions. You're not allowed any time to recapture any materials in a building. You're already on the wrong starting point.
Okay, thanks, guys. So hopefully we've got a bigger stock of steel. It will expand. So how do we go about finding that steel, and what tools are there that are available that people can use to actually source this steel? And what else do we need? What other tools do we need? How will we grow this? Andrea, can I ask you that question first? Is that something you can answer?
Sure. So I think there's actually lots and lots of different ways of finding materials, and that's possibly actually one of the problems as well as one of the good points. So obviously we've got Roy here, who has steel. Excess Material Exchange is another platform that you can use to find all sorts of reused materials. We were doing some work through the Circuit project last year, trying to understand why these platforms kind of all existed. They keep being created. There's a lot of new platforms that keep being created. And one of the triggers we thought might be an issue is critical mass. So if you are trying to source some steel at the moment and you don't have your own donor building, which is definitely much more simple route, you've got to go check a lot of sources. So one of the things that the Circuit project has prototyped is kind of an umbrella one-stop shop aggregator, and the idea being if and when any digital platform, has an inventory, they can all be read by one place, so you can go to one place to find out what is the stock that's available. I do think there's a challenge with that, and I think it might be what Tom was touching on, is that you actually don't really need to know what's available right now. You need to know what's likely to be available when you're building your building. And to my knowledge, we're still quite away from having that level of insight for designers to be designing for a theoretical reuse rather than quite a specific reuse.
I mean, I'm of course biased, having a platform that's trying to facilitate this, but there's many platforms out there that are trying to achieve the same. I think also HTS, Laura presented it on Footprint, the stock matcher, I believe it was, which I think is a great tool as well for unlocking more supply of steel. But other than platforms, you also need passports. Madastra, of course, is an example of that, as well as our own platform. You need tracking and tracing. You need to understand where these materials are, in which state, what is the life cycle left on them. Like I said, having information on the embedded impact is very useful as well in understanding where you can get your biggest bang for your buck. And indeed, these integrators. And I would say, I think a lot of platforms, and we're also guilty of that, are becoming sort of islands of data and are becoming in some ways centralized, but don't have the ability to communicate with each other. And there's an interesting project also now in the Netherlands called DSGO or DSGO. I forgot what it stands for actually, but it's trying to develop these protocols on how platforms can exchange data with each other, kind of like how banks are also working. So if you're making a transaction from one bank to another, they have a way of communicating with each other. And I feel like that's also where the way that data is being stored on materials should move towards as well. So you can say, okay, I have this stock of materials in these passports, and I have these protocols which can prove that I'm meeting certain requirements to be able to exchange this data with other platforms. This is something that we didn't think of when we just started the platform many years ago, but I think it's actually a key element of it, that we can link all these different data islands together, and then in that way unlocking all this stock of materials out there, not just steel, but any material in any industry, ideally, to be honest, because there's, I think, a lot of interesting exchanges to be made, also looking at other industries.
I think there's definitely a point there in terms of we've collected a lot of data, but the real what makes a difference is how you use it. So, I mean, there's been some great work done on stock matching tools, which allows us to allocate steels. But then if we can start integrating that into BIM and allocating kind of product passports, material passports for those, there's a lot more value you can get out of that.
And that is definitely the way in direction of travel. I mean, as more data is available and tools become more sophisticated, we will see that at some point it will be incredibly easy just to match existing steels with new steels. But it takes effort and it takes investment as well. There's many players, many companies developing these tools at the moment. How do we share that data? How do we learn from those lessons? And how do we make them, even using the keywords, more intelligent, to learn from what they are creating? At the moment, they match existing stock against design elements using genetic algorithms. But what else can we do? How can we make that more efficient?
That was going to be my next question, actually. Roy, have you got views on this?
I think one of the things that's very important, that's critically important in my opinion, is because the matching tools are fantastic, but it's a question of when you ask the question. And I don't have any confidence when people approach me early design stages that what they're going to build is going to look anything like the thing they're asking me about. And I don't think most of the engineers in this room believe that's going to happen either. So there is a problem, and excuse me for this, but a friend of mine once said, I've got two balls and neither of them's crystal. You can't predict what's going to be the case down the way. So ask the question when you know the answer is going to be the one that you can work with, because it saves everybody a lot of time and effort, and it doesn't let yourselves down, making promises you can't keep. So that there is not the inventory there that people would like to be there. So if there's only going to be, and we heard Jonathan say earlier, putting 100 ton in a 3,000 ton project, that's laudable because we haven't got tens of thousands of tons to feed in. If you know that you've decided that 5 or 8 or 10% is going to be an acceptable thing, it's moving the whole direction of travel. Everything's pointing in the right direction. It's going to be more attainable and it's going to be more realistic. And one of the things that bothers me the most at the moment are people making big claims on bids they make, which realistically just aren't ever going to happen because the thing will change or it won't happen, the money will just, it doesn't matter. So many different reasons they go wrong. So ask the question at the right time. And then, as I say, don't over egg it. The material, the commerciality will sort itself out. Material will become available because people are buying it. There'll be a lot more scrap men suddenly decide, especially with the way prices are going just now, there'll be a lot more of them suddenly looking to shift it out into the marketplace for another 50 quid a tonne premium or whatever than there were 12 months ago.
I think there's more than one approach as well in terms of when you can actually start integrating your reuse still into the design. So there's that kind of approach where you fix the design and then you look at what stock is available and what matches. But if you can actually engage at an earlier stage, you can actually start looking at what's available and how that can influence your design, so you can make your design more flexible and then allocate your existing steel stock. And by kind of taking that approach, the advantage is that you can actually start maximizing the reused steel and minimizing the kind of carbon and the efficiency of the design. But obviously the caveat to that is that if you're doing that at an early design stage, you've then got to take into account the cost of storing the steel over a long period of time. So there's a balance there in terms of when do you start allocating and securing steels for design.
But there is a reason why that happens, and it's because the design process is very dynamic, but at the same time it's very static. And the design process takes into account uncertainties at the beginning that start getting clarified as you develop that. And in some cases, that is because there is not enough detailed engineering input at the early stages. Now, we're seeing with, for example, requirements from the City of London to assess at a pre-planning stage 4 different options for buildings. What it means, when you need to justify demolition, you need to prove that you can use the existing building, and you need to show more than 4 options for that case study. What it means is that at a pre-planning stage, we need much more detailed engineering input. If we can bring that level of engineering input to any project, if we can bring that level of certainty to any project at the beginning, then we could do what Tom just mentioned, which is design with the stock in mind, rather than struggle with what Roy is struggling with, of not knowing what the building is going to look like in 6 months. If we can bring more engineering input to the beginning, we can definitely add more certainty to that process.
And maybe also try to incentivize the project developer to pay for that, because obviously, especially in this phase, it's going to be slightly more expensive. And we've seen it now in a project here in the City of London, where the architect that we work with, which is a very famous Danish architect, GXN, 3XN, they've developed a number of options for the developer, and highly ambitious, adopting a lot of circular economy principles. But now we're seeing that costs are starting to play a role, and they're starting to maybe come back on some of these plans that we've presented, which I think is really a shame, because there's, like you said, the impact that you can have at that moment in time is huge.
I think just a final point, I think a lot of this feeds back into the kind of the availability of the stock. So the challenges with our certainty in terms of how much steel we've got in the design is this is all down to the kind of the limited availability of stock. So it is a kind of a stopgap solution, a lot of these stock matching kind of things. If we can then focus on driving the availability and actually sourcing the steel, then we kind of solve the problem in a way. We can scale it up to the point where we've got so much supply that we've got that guarantee that you can bring it in at any point. You get around these issues.
I think that's key, scaling up, because that way, when you have a certain critical mass, I think it goes out to what Andrea mentioned about not necessarily knowing the exact piece that you're going to use, but the likelihood of getting that sort of piece, which means that you need a bigger sample so that you can get some statistics from it. So you're not designing for that specific section, but you're likely to get something like that.
Anything for you, Andrea?
Yeah, it's another thing that we were exploring through the circuit project in a different way, and that was how, again, it's not going to solve the problem right now, but the whole point of circularity is supposed to be designing for circularity, not just being circular right now. And we were looking at how can we use like materials passports. If we had materials passports for a geographical area, we know, unfortunately, how short-lived most buildings are. And therefore, if you had that level of information stored centrally, you could do the hypothetical analysis, like, all of these commercial buildings, they're probably going to be knocked down in 30 years, and this is the distribution of steel section in them. And there'll be massive error bars on that, but actually the conclusions that you'll draw will be useful for informing your design. So again, that was all it's quite theoretical and future thinking, but like those ideas and the prototyping is there, but we do need the data to use to make any of these things, give us the real answers.
Yeah, I think in an ideal world, you would have these buildings as sort of like material stock for future buildings.
Yeah.
You could even then sell these materials. You can even sell the options on these materials. But I think the financial industry will probably have manipulate that into something monstrous as they would normally do. But at least I think it's quite interesting. Then you maybe also solve that issue around timing, where you can buy the option on that material before it sort of matures in the next 5 or 10 years or so, which I think we worked with ABN AMRO for a while to look into that. We loved it, they also loved it, but I think the market is not ready for that yet, I think, but it's something maybe that we can sort of aspire to.
There's one thing that's relevant to inventory that's very important, and I think didn't get mentioned the last time. Just remember grade, please. So you want to design things out of old steel. It's going to be old steel. Every inquiry we see at the moment is for S355, and then everyone has to get fed back through to find out if S275 is going to be okay or not. And now we've got P440. I don't even know what the grades are supposed to be when you get back that old, but in theory, you've got that kind of material can find its way into the system. If you want to be flexible, the first flexibility has got to be grade. Make sure that at least the details that are issued take account of grade, or the fact that you might have to use a lower grade material than modern.
Okay, thanks all. We'll open the questions through Slido, but just to pick up early on what Diego was saying about the cost of removal and trying to incentivise, just from our experience between the two projects that are over there that Miles and the team were sort of going through earlier, all the benefit at the moment is with the recipient project. you know, if we hadn't had those two projects, over the two projects, the costs equal pretty much the same, but getting the steel out and how that works in terms of cost and program has definitely been a penalty on the donor project. The Miles is taking all the bruising, whereas the project manager working on the other on 180 Piccadilly is taking all the benefit. So how we get past that will be quite interesting, actually. But I haven't got any clue how that's going to work. But Andrea, do you?
Yeah, well, I guess that's where the more systematic enablers come in. So things like the London policy, which is now putting more emphasis on, well, firstly, knowing what the building is if you're taking it down, and then, in theory, more scrutiny on what's happening to those materials. Then that creates another incentive. So it's not just the cost for, you know, the nice feeling of being able to do it. It's like, actually, it's a planning condition that I have to recover a certain proportion of my steel. And then it's the bigger picture. You'll have more availability. Like that was kind of one of the key things. If no one takes the building down, then there's not going to be any reclaimed steel. You cannot get your low carbon reclaimed steel if you don't take the penalty of recovering that steel from somewhere else.
And I think also that circular economy, those guidelines from GLA shouldn't be underestimated. I mean, the reason, to be honest, that I'm now in London is because of that, because there's been so much more demand for our services, which I think is really great. And maybe that's also a bit of, I don't know, silver lining from Brexit, because I feel like maybe the UK is now, you know, moving a bit faster when it comes to this sort of regulatory pressure, which I think is really crucial in adopting circular economy principles. I really think that's really fantastic, and it's creating a lot of work for us, which is even better.
Okay, great. Let's take some questions. So from Johanna, do people know how to ask? Do people know how to ask for you still, or is it just fair few who do? How do we know how to obtain this new steel? Does the industry understand it?
Broadly, yes. To say there's a question of...
Sorry.
That's fine. So yeah, it's remembering its older material. And there is also, the one other factor after grade is the fact that people tend to forget the material has to be made to fit the application if it's reused. If there are holes or there are attachments, they have to be taken account of. In utopia, we'd all be taking down portal frame sheds and chopping out whacking great lumps of beautifully clean steel between the connections. That's not the case. So even when you know material's available, it has to be assessed against its application, not just in engineering terms, in absolute practical, does it fit, can it work, can I do with it what I need to do? And then, of course, which most people also are aware of, is will the client accept it afterwards? Because if it looks not as they want it, that could be a problem. I don't think, based on the level of inquiries and the way we've seen the market move, people aren't finding it difficult to find people to ask for the material if they want it.
There's definitely a lot of people asking for reused steel, but I think what we need to encourage is people asking what they can supply is the big one in terms of what can you give. Even if you don't have, a lot of people kind of look at, say, we've got this bit of steel, how can we use it? But we don't want to discourage reclaiming that steel just because you don't have a specific use, because within that marketplace, if there's good steel, there will be a good use for it. So it's that kind of balance of not being discouraged just because you don't have a building to put it directly into, not to discourage the reclamation.
I would say the capacity is there, but we're also still stuck in sort of linear processes, which leads to a lot of material getting wasted, basically. So, you know, it's a systemic change, like Andrea is saying, so it needs a systemic approach as well to basically empower these experts and specialists, like Roy, to be honest, and maybe in some ways like us, to do what we do best, which is reuse materials.
Okay, next question from Marius. 180 Piccadilly is not the normal regarding designing from a catalogue. Would it be plausible for a structural engineer to size steel on minimum characteristics such as depth and length on drawings? Thomas, probably one for you. You're old.
Yes, it is. Yeah. So, well, I mean, 180 Piccadilly is actually quite unique in how it was designed. So there is opportunity there to kind of, rather than specifying individual section sizes, you look at kind of performance specifications and say if you have a steel section size that fits that performance, as long as it's not inefficient, that it's appropriate for use. So you're not, you can get a bit of flexibility, which actually once you build that flexibility into the design, then you actually start looking at a much higher potential reuse percentage. But then the other side of it that happened on Piccadilly is that they actually looked at the available stock that was there in the donor building and looked at how that fit into the new building, and can you actually change the design? So the scheme design changed, the framing and the grid layout actually changed to fit, to match the available steel sections, which actually allowed for a really efficient use of the reused steel.
One thing that we're also now working on, which is quite nice, I think, is part of a Horizon 2020 project with a number of airports in Europe, where we're working with a French consultancy firm to create a catalog of sections and elements that are almost always used in airport structures. And that helps in two ways. It helps the demolition contractor to take out these sections, create a bit of standardization there, but also helps the designer and the architect for the new, whatever terminal it is or hangar or whatnot, to then use those elements and sections in a useful way. I mean, this is still ongoing, will be done, I think, by the end of this year. I'll keep you updated on that, but it's, I think, an important piece of work.
And just to add to what Tom was saying, that is engineering input at an early stage. And currently, the matching tools, they match based on sometimes inertia. They match based on cross-sectional area, properties. They check what you have chosen against the existing based on mass. And they have parameters, plus, minus 20%, etc., to make it efficient. But that is just the starting point. This is where we are right now. In 6 months' time, these tools will be able to match the profile itself against defects, and dents. And the panel before was talking about the engineering input to see if this particular section can fit this purpose, because this piece of damage might not be necessary structurally. Where the tools that there are right now don't do that, but in the future,
definitely,
it's so easy.
The allocation is just a starting point. I think it's feeding it back into the design. That's when you start really kind of hammering home these efficiencies. That's good.
I think it's quite interesting, though, because it shows how far away from a business as usual structural engineering design using reused steel is. Like, most designers are not taught to think about material properties, or maybe they did the lecture on it, but then they got into practice and, used the standard books. So it's almost you've got to relearn the basic engineering as well.
It's funny, though, because we all play with Legos, and this is basically what it is. You have the Legos.
Yeah. I think, and we've got to remember that what we've got in our stock is not just a random selection of different lengths and sizes. When we've taken them out of building, the buildings have actually been designed to standard grids. So if you've got a 6 or 7 meter grid in a building coming out of the frame, if you want to put it in a 5 meter grid, you're automatically losing that 2 meters. If the opportunity there to match the grids to the donor building, then you can start looking at improving the efficiency. But that isn't a way we've designed traditionally before, by looking at stock. So it's kind of changing that mindset from the designer side and having that engagement and being open about what's available and what we've got, which can really kind of push these things forward. Yeah.
Yes.
I'm going to be contentious on purpose. It's not all about engineers. If people come and ask me, have you got some of this steel? I can sell you the steel that you are asking for if I've got it. And if I've got reused steel, it's going to perform the same unless I inform you otherwise. And that's only one engineering question. That's not umpteen iterations of a building. That's a building that you've designed that's going to work, that I can offer to put reused material into in a manner that isn't going to affect how that works. The other thing is that if the engineers don't all find ways of consuming my stock, I am going to find ways of selling it. So it's not a case that it has to be this, and I'm sure it works for engineering companies to have multiple iterations and for things to take forever, which is what seems to happen. But it could just be the normal design process with a clause that allows you to incorporate used material. And then simply a simple feedback loop, one loop, that checks the material that's been input at that stage to make sure it's appropriate for use.
I think we have to sometimes accept that actually sometimes the reuse steel isn't the actual appropriate one. It might have a better use in another building, so we don't want to be forcing it into our designs just because we want to have that tag of this reused steel. If it could be actually have a better potential carbon saving in another use. It's a really important caveat to that, yeah.
Okay, I think the next two questions are actually sort of linked. So we're reliant on stock at a point of dismantle or quantities held by limited stockists. How do we get better visibility? And what advice do you have for dealing with today's time lag between designing and buying steel? How do you prevent people buying your other people's sections? Gazump.
Well, I wouldn't let anybody gazump, but I can foresee a situation where I only actually give prices in the way that I price new steel. So I can see a situation commercially, being totally candid, where I'm not interested in what you want in 9 months' time, back to the quote I just gave you. Mm-hmm. Come and ask me when you've got some money in your pocket and you want to buy the stuff, and then I'll sell you something. Because, and this is going to go into areas that have been discussed later, I don't want a contract. I don't want to be suing you. I don't want you claiming on me. We're a business with 50 employees. I'm not going to court, because if I take you to court, you're not going to buy from me ever again. So the true realities are that we need to agree a deal when you're ready to do a deal.
Yeah.
If you're going to be grown up about it and you want to give me a whacking great deposit and forgive me later when you don't want the metal and I've kept it, happy days, but I'm not expecting that to actually play out very often in real life. On top of which, we're in a market now where prices are crashing, and the thing that scares me the absolute most about these 6 months forward, I agree today I'm going to sell it to you for £800 a tonne. The prices have dropped £400 a tonne in the last 4 months. So in 6 months, how many of your clients are going to be honourable enough to pay me the far too much money that they've now decided that I've quoted them and tied them in for? So there's a lot of just very simple, boring, real-world stuff that actually might serve to simplify a lot of this process, never mind anything else.
Okay. This is an interesting one. I've not actually thought back to the third question down here. So if you over-incentivise steel from existing building projects, do we risk premature demolition of structures that could otherwise have had their life extended?
I have a view on this. And it's when you kind of started talking about the futures market and that kind of stuff. So I think if the building works in situ, then that's the best place for it. And we definitely don't want to be having the steel being a commodity in a building that someone's trying to get back out because they can get more money from it. I think luckily the buildings market doesn't really seem to work like that, but that is definitely a danger if we do too much of that kind of future selling kind of thing.
Yeah, that was also sort of the shadow side of those conversations we had with the banks, where they said, oh, maybe we can demolish these buildings a little bit earlier because it's worth more. But the other side of it, maybe we can also extend the life cycle of it a little bit if the value is low right now. So it's, it's a bit of give and take there, but indeed it has some negative sides to it as well. But I think maybe overall, if we were able to do this, then the circular economy would be a natural result of this, which I think overall be much better, really.
And I know this isn't necessarily a big policy kind of discussion, but I think that's where, policies, whether they're local government policies or national fiscal policies, can help, make sure that any commercial or financial decision that's made is within a ballpark that everybody would like it to be in.
So I think it's probably a problem that solves itself. I mean, if you think about it in the current marketplace, you've got demolition contractors who aren't sure if it's worth their extra money to get metal that's worth recovering. I can't see somebody flattening a whole building with its entire asset value, whatever it is, to recover what's actually bugger all of the metal out of it.
It's going to be a pretty poor building.
And I see it with the reuse content going in. You've been conversations about, again, the finance, but the values of money are tiny compared to the project.
Yeah.
And I think that's always going to be the same with when the thing comes down. It's always going to, if it makes sense to leave it up, it's always going to make more sense to leave it up.
Okay, question from Tom Webster. Are current procurement routes for projects fit for purpose when considering circular economy and materials availability? Any views from the panel on that?
I think procurement is one of those sort of elements of that process that I think needs to be updated. I think what we've seen with some of our clients, which are a lot of them are government agencies or government-owned entities, in some cases they had in their procurement policies that something has to be new. And I think those are very simple things that you can update. So at least just in a very simple way incentivize these procurement people to look for stuff which has been used before. So I think procurement is really the sort of the key that unlocks a lot of this value. So I think it's a great question, to be honest.
And there is so much into it as well, like public perception. In some communities, their aspiration is to have something new rather than something repurposed or reclaimed. But I think Penny mentioned the key word, which is transition. This is a transition. It's the next 5-10 years, we'll all work towards getting to this destination. And everyone is at a different speed, different pace, different stage of maturity. We just need to get our heads together and push forward.
I think the procurement for me that doesn't work is not necessarily the procurement of the steel, it's the procurement of a building project and that whole process and how we kind of try to cascade aspirations through a design and build process. That's the bit that I think doesn't really seem to work. You don't want to take the risk early on saying it has to be 50% reused, and then if you put a clause that's saying reuse as much as possible, you're probably not going to get very much at all. And so I think that's kind of actually one of the big procurement challenges, is like that, rather than necessarily how we buy the steel, which will probably sort itself out.
Okay. Question from Bill. In order to extract more reusable steel, can we optimise the existing BAU models, or do we need to develop new supply chains to incentivise harvesting? Must admit, I'm not sure what a BAU model is, to be honest.
Business as usual.
Sorry. I thought that's a technical word. Sorry.
I mean, definitely no incentivized harvesting. That goes against what we said.
I guess harvesting when demolition is taking place.
Okay. For projects and buildings being built now, are we capturing the correct material passport data to ensure the steel stock can be, but not use limited stock most efficiently? Any thoughts?
That's interesting. So is that collecting the data on the stuff that's coming out?
Yeah. And being rebuilt. Actually, sorry, that's designing. So yeah, trying to creating material passports, I think. Yeah,
I think there's two sides to this. One is understanding what we've got in the existing building stock, and the other thing is when we take it out into the stock is actually developing the passport. So one thing that we're looking at is actually providing product passports for every single steel member, which is that kind of all the information on the testing that feeds into certification feeds into that, and then that is actually available to go into the new building's BIM model. So as long as that is correctly stored and recorded, you should be able to, in 50 years' time, go into your 3D model, click on an individual member, and find all of the the testing and certification data, the section size. So I mean, there is a lot of work there. There's a lot of kind of potential there for new buildings. But really, I mean, that's a benefit 50, 60 years in the future. What we really want to understand now is that what do we have in our existing buildings, which is bit more challenging because it's dependent on archive information and surveys, and pushing circularity now in our current demolition. We need to think about how we can actually start building up maybe not individual passports, but building level passports that can kind of give you some kind of quantitative of like, this is how much steel you've got in here.
And it also requires early involvement of these specialists to make sure that you have the time to get the right data, to make sure that you can make full use of these materials for their sort of next life considerations. So the earlier you get involved, maybe a year before demolition, 6 months, something like that, so you can get into that building, do your visual inspection, maybe do some testing here and there, so you can collect all the data you need that will help in finding that high value next use, I think is really crucial.
I think it's not just when you're deciding to demolish. I think if we can get it before that stage, just so you can understand what you've got on a building level, because it can also inform the plan for refurbishment as well as deconstruction. So these kind of information, I think there is a big, the big use there, amount of potential, and it's just making sure people understand that the value of actually having that information.
I think large renovations would also be a very good moment in time to go into the building and sort of take stock of what you have. But there's a balance there, right? Because the legacy stock that we have out there is, of course, enormous, and the cost of mapping everything are equally as enormous. So I think that there must be some sort of You
need to do some high-level kind of judgments first to say on feasibility, and then if you think it's more feasible, then you can start looking at more detailed surveys, more detailed kind of looking at the archive information. Yeah.
I think it's important with steel to remember there's limited things that are important to know. So grade is it. It infuriates me that, they used to emboss, Nigel's nodding, you remember, they used to put the grade on the web, you could actually read it on the thing. It was there. They stopped doing that, so now you've got to test it to find out. But if you know the grade, everything else is going to be pretty much subject to inspection after demolition. And the thing is, steel can be made shorter, made longer, it can be turned into something else altogether. So you do need to capture its original use, and you need to know what the grade was, but nearly everything else after that is subject to change or subject to interpretation. So it's important that data is able to be carried forward, and especially the test certificate stuff has got to be tied in. And I mean, our inventory system's done that for 20 or 30 years. We can tie everything back to specific numbers for every piece. But after that, you've got to remember that most of what you're otherwise going to know about it probably won't be the same anymore by the time it's come out of the building.
Yeah, I mean, this is where the SCR is coming really helpful with the guidance in P47, is that having that high-level acceptance criteria means that you can answer some of these yes-no questions. If you've got an existing building that's pre-1970 or pre-1930, before you start digging into doing these surveys and testing and all this other stuff, you can actually just take a really high-level judgment of, is the steel reclaimable, based on these kind of high-level categories that don't take a lot of effort to know the age of the building. Yeah. So.
Okay, next question, actually, which is a good one. How do we avoid over-designing to basically use reuse steel? How does design of available stock result in over-design? Might help an individual project, but not use limited stock more efficiently.
I mean, I think this is the question that Michael tried to answer earlier, and that there are studies done kind of looking at how much over-design might be okay in like the global picture to still be like kind of having a carbon reduction. And there's like the 25% kind of over-design is the kind of one of the numbers that's bandied around. I also have a slightly different perspective on this as well when I kind of go into my theoretical circular economy thinking, is that like when we think about circular economy being inspired by nature, actually nature isn't actually that efficient. Nature is circular. So if we are reusing something and it can be reused, actually, then it almost doesn't matter too much, if it's over-designed or not, because it's still a resource. We've not devalued it in any way, and it can still be reused again in the future. That's just a personal opinion, though.
I think it's a really tough question because it's about, well, first, all the conservatism within engineering. But let's put that to the side. Let's say that we are all designing incredibly efficiently, then, which we're not, then how do you reuse the sections efficiently? And this is where tools come in, because the tools can have parameters where you determine when you match a section, this is the maximum range, this is the maximum size, the maximum weight, the maximum waste. Tom was saying that if you change the grid from 7 to 5, you're losing those 2 meters. Well, the tools that colleagues are developing can look at that waste, can give you a score in relation to carbon emissions, amount of waste, number of pieces. If the section is reduced to 2 meters, then can I use it somewhere else? The tools are smart enough to do that. And the more that we develop machine learning and AI and then bring that into these tools, we can find ways to match them much more efficiently.
Yeah, I think there's a little bit more flexibility in terms of the efficiency because there's a massive carbon benefit with reusing steel. So you don't have to design it at 99% efficiency to really maximize that.
I guess the more stock we have, and the more we make our design tailor to the stock that we think we're going to have, the less use we'll be doing anyway.
Another consideration, though, is a big one, is trying to move away from bespoke design. So we've been talking a lot about existing features and what we're looking at use cases, and this steel might be better for this use, and if you flip it over and stuff like that. But what we're kind of wanting to do as designers is, if we can provide it in terms of grading or classifications, where you can actually just say, right, this is a structural grade, and then you know what you're designing to without having to look at each individual steel. You can kind of categorize them. You can build that into your design software and just say, these all categories have different design parameters. But it moves away from looking at individual members and having to make an engineering judgment on every single individual member. And it's having confidence in those grading systems and having the test data to back it up. You've always got that data behind it, where if you do want to look at an individual member, you can do. But it's kind of making that design process more efficient in terms of just being able to group members and then allocate them in terms of your design. Yeah.
And bringing the principle to the beginning. I mean, Tom was mentioning about use it to design in based on the stock that you have. So the tools that the industry are developing right now actually look at a grid. Let's try this grid in this floor plate, and let's see, based on the stock that we have, how much can we reuse. But testing another grid, and not normally 20 years ago would have taken weeks. Now it takes seconds, and we can test hundreds of different grids and inform that decision from the beginning. If you use a 6x7 grid here, a 9x12 here, and a 6x15 here, because we have those sections, we are using those sections in the most efficient way. So the way these tools are going is just mind-blowing at the moment.
And it's a transition, right?
Exactly.
I mean, we're learning. We just don't overanalyze. Just make the first steps and do it with your eyes open and learn.
I think just to remind more than anything, I'm sure most people are aware, but at the end of the day, can fall out about the number, but roughly if you get to 25-30% too heavy and you've stopped it being scrap, you prevent electric arc furnace steel being produced, which is roughly 30% of the carbon cost of blast furnace steel. So there is a consequence. By reusing, we're actually causing less electric arc furnace steel to be available. So there is a responsibility to ensure that that's done responsibly, so that it's not having that knock-on carbon effect. Because at the end of the day, to me, all the decisions should be taken of what's the carbon impact today, not just what's the carbon impact of my project.
Yeah.
It's what's the net carbon impact of the decision I've taken. And I would actually, again, to be contentious, I would argue it's probably far more important to make the designs efficient than it is to make the reuse efficient. I suspect most designs just aren't efficient in the first bloody place, so it doesn't really matter whether the 10% of steel reuse is particularly efficient. I think that's been proven in academic papers time and again.
Yeah. But I think it's something, because obviously we've looked at that balance between when is it better to recycle in terms of what is the efficiency, and we keep saying about 70 to 80%. But that's something that you can actually just put into your design tool and then say, look, if it's below that threshold, then actually you should be recycling it. So, but I think the biggest point in that is, where do you take that threshold? And that's what the research has been looking at.
I know the HTS tool, which is the one I've seen work, that actually tells you what yield you're getting.
Mm-hmm.
You can know how well you're utilising the material it produces that number, so you can see.
Okay, good stuff. Next question from Nick. Who's best placed to help drive up the quantity of reused steel, used material? Clients, engineers, demo contractors, mandated planning requirements? I guess is it all the above, but
everyone, yeah.
All of the above, right? I mean, it's a systems change. You need the whole value chain to work together to make this happen.
And the project managers.
And the cost consultants.
and the QS.
Yeah, the cost consultants.
Any other thoughts? I mean, the planning is obviously driving quite a lot of this now anyway, which is good. I think because there's going to be clients who will embrace this.
I think that planning will help a lot. I don't think it will, on its own, drive up the availability of sections for reuse. I think it will need more than just planning at the moment for that.
And how do you make it attractive for the donor building is the big question, isn't it?
It's already attractive for the donor buildings because recipient buildings.
Yeah, exactly.
Yeah, making it attractive for the donor buildings is going to be
big one, yeah.
The
tricky.
current RICS proposal of making the demolition be carbon accountable for the project rather than the asset, I'm all on board. That's, again, it's a carbon consequence of today. I've always found it rather bizarre that you're allowed to work out the carbon cost of your project when you knock it down in 60 years and completely ignore the thing you just did because somebody accounted for that theoretically 50 years ago. If we're going to hit the targets for 2030 and 2050, what we have to do is make less carbon now. It's not the jam tomorrow scenario of making promises that nobody will ever know whether you kept. But for me, if demolition activities are forced to oblige, not the demolition activity, that's not fair. If the person that's decided to flatten a perfectly good building is held to account for how much carbon that they've just flattened and offset it against what they build, there's been some pretty different decisions made very quickly. And I accept it might not be very welcome in the new build industry, but it's the logical.
There needs to be some kind of. So at the moment, most of the carbon saving is kind of attributed to the building that uses the steel, not the building that recovered the steel. So if it's going into the marketplace, that kind of gets lost. So we want to be able to give some credit to the people who have actually gone out there and taken the steel out of the building once it's been deemed that it's appropriate to do so, that they can actually start kind of reporting or at least saying, look, because then if you can then you're incentivizing changing those waste routes away from landfill, away from recycling, and towards reuse, not just for steel but for all materials, if you can actually start putting some carbon numbers to it.
An interesting thing that could drive that, and looking at different levers and the planning, is actually like quantity of waste generation. Because if you're reusing it in waste legislation, it does not become waste. So actually, if those targets were on quantity of waste generated on the demolition, then that's the kind of thing that would really drive reclamation and reuse.
We really need to start differentiating as well recycling and reuse, because at the moment there's a lot of recycling targets, but actually that's missing out a lot of potential reuse. So we can start actually separating those out, and actually there's a real carbon benefit between reuse and recycling that we need to start looking at and capturing.
And also regulation on embodied carbon, but also shadow price of carbon. I mean, the current let's call it carbon tax, is just not adequate. But if you increase that tax to, say, £200 a tonne, then it makes sense. The savings that you get from repurposing steel add up.
Okay, we've got 3 minutes left. So I think just what would you want to say as a sort of closing statement on how we need to do things differently to really encourage the reuse of steel and other elements as well? Actually, start with the far end, Thomas.
Yeah, so I think for me it comes down to the supply and just raising awareness of that, the opportunities for reclamation. It's that if we can actually start really getting the stock larger and kind of encouraging the supply side, then a lot of these problems that we're facing now naturally kind of go away. So that's the part that I'd be pushing for.
Excuse me, I will focus on tech, invest in tech. We are seeing it happening all around us. Disruptive technologies that can really drive this forward. In the last 12 months, I mean, many of us have been developing tools which are in their infancy, and they're doing things which by hand would have taken us months. What is the future? Well, it's incredible, but it needs investment now.
I'm also a tech optimist, but I think a lot of it also is that we're now stuck in a lot of linear processes. So I think if, Duncan said it well a couple of years ago, I think at Waste Built in the Netherlands, where we should harvest before we build, harvest before we design, look at what we have and integrate that into the design and development processes of these projects, I think will create a huge push for finding the supply and then making use of it. And that has it's simpler said than done, but it has a lot of elements in it from a regulatory point of view, from a structural point of view, you name it. But it is like a systems change, but it starts with this desire to start harvesting materials before we start designing and building.
Can I have two?
Go on then.
One builds on the tech theme, and it's going back to my idea of looking at the future. To solve this problem that we're having right now in the future, we need to be creating data now. So even if you're designing a completely brand new building, please capture the data on it properly, so that the problem we're all talking about now is not a problem in the future. And the second thing I want to do for right now is more things like this, more talking about the case studies, what has been achieved. I spend a lot of time talking with clients and planning officers saying, it's new, or it's difficult, or it's not possible. The more you can share, everybody, about the small and big successes, the more like business as usual it will feel, and the easier it will be to overcome the non-technical barriers.
Thank you, Roy.
Very basic for me. It's to think circularly and outside your box. So look at the thing that you've been asked to do and see if it can be done better in circular economy terms. I know from working with a couple of demolition guys, they've been able to recover 5 or 10% of the steel on a current demolition contract without changing practice. But they have to be asked to do it, otherwise it gets chopped up and thrown in a skip. So just think circularly, look at and then ultimately it will all advance.
And my thoughts are we just need to learn from each other. I think closed shop, using your own tools and not sharing how that tool works, and we just need to share. We need to learn the stuff we're doing. We're certainly more than willing to start sharing how there's been mistakes along the way that Tom and us have found. But yeah, it's all about improving that way we're doing it. Just to say thank you to the panel. Been a really good discussion, hopefully, for everybody. And I think the award for the quote of the day goes to Roy. Try and better that one. Thank you.